I'd like to welcome you all to this Learning Technology Innovation Pilots webinar. My name's Simon Bates. I'm Academic Director for the Centre for Teaching, Learning and Technology and Senior Advisor for Teaching and Learning. And I am going to be emceeing this event over the next hour. I'll be introducing a number of presentations. We're using a platform called Shindig. We've partnered with Shindig to present this event, and grateful for the support that they've extended to us in enabling it. If we could go to the next slide, please. What I'd like to do in this short introduction is just tell you a little bit about what we're doing here, outline the program. We're going to be talking about two areas of learning technology innovation, where we're looking for questions, ideas, and your input to help us determine which areas to focus on. And I'll get to the specifics of how we do that towards the end of the session. And you can see on the slide the number of people that we've got from around the faculties at UBC who will be presenting short overviews of some of the work they've been doing in this area already. Next slide, please. So really the purpose of today's session, as I said, is to really get you thinking about what are the interesting questions and areas for us to support some investigation in two areas of what we've termed learning technology that's not quite here yet: learning analytics and 3D learning. I've just been passed a note to say, can everybody see me? Maybe if those who've got video turned on could just nod or wave if you can see me. Yep, I'm seeing thumbs and nods. Thank you. So two areas of what we're calling not quite here yet, in terms of either the infrastructure and the capacity around UBC. That's certainly the case around learning analytics. We have some deep pockets of expertise, but certainly not at the moment. We don't have real broad institutional capability in these areas. And also 3D learning, which, as you'll see on the next slide, is a fairly broad term to encapsulate what we're thinking about in terms of mixed reality, augmented reality, and virtual reality. If I could just, thank you, just go back to that slide. We're really looking at trying to, next slide, develop a learning community to build some capacity around this. And just a couple of things, a couple of fairly obvious statements, I hope, about what this call or this call for expressions of interest is not. These aren't fully formed proposals. These are innovation pilots. So they're not the same as some of you might be familiar with TLEF projects. There's not an expectation that you come formed, a ready formed project idea with a clearly defined question, middle, and end point. They're much more experimental and open. And indeed, part of the follow-on work that we'll be doing is working with people to help understand where the interesting questions might be. So let me just say something in terms of interactions. Shindig is a very, very interactive platform. It offers a multitude of ways to interact with presenters and indeed interact as participants or members of the audience. We're not going to use them all today. We've got a fair number of presentations to get through. So the two methods of interaction that we would like to propose that we use today are that you can ask a text question at any time. So in the bottom right of your screen, you should see a little icon bar like this. Text question is the question mark in a little speech bubble. Please feel free to ask any questions about any of the presentations in real time, but we will respond to these offline. We'll publish them back to the participants and also share them more broadly on the web, along with the recording of this session. But there will be the opportunity to ask questions in real time. We'll have a couple of question breaks after the presentations for each section. And what I'd invite people to do when we get to that point in the presentation is to raise your hand. That's the middle icon on the little bar. And when you have your hand up, The moderator may invite you to come to the stage, so you'll join me up here at the front of the room, as it were, and you'll have the opportunity to ask your question. So if you do that, please make sure that your microphone and your video is on. But text questions at any time. All right, next slide, please. So the first couple of presentations that we're going to talk about showcase some work that's underway in learning analytics. So this is how we're defining learning analytics for the purpose of this project. It's actually the definition taken from SOLA, which is the Society for Learning Analytics Research. And we have three presenters who will give a short overview of some of the work that they've already been engaged in at UBC. So bear with us as we shuffle presenters just for a second, and they'll introduce themselves.
Hi, hello everyone. My name is Ido Roll I'm the Senior Manager for Research and Evaluation here in the Center for Teaching, Learning and Technology. So I'm going to talk to you briefly about learning analytics together with Leah McFadden, my colleague from the Faculty of Arts. And we are to present a call for, next slide, thank you. And another slide, please. Thank you. So the goal here is for us to figure out how actually we can use data to improve student experience, student learning, and teaching at UBC. So what you see on the slide is kind of fairly obvious. We design courses. The way we structure courses facilitate learning. And that is true for on-campus and distance, any hybrid form of that. So that facilitates engagement that leads to learning. Quite often this engagement leads and produces data. This data so far is being stored deep in Vault somewhere, is not being used well enough to close the loop back to course design. If you could advance the slides, please. And that's what we're looking to do now. How can we use data that is produced as part of our teaching and as part of student learning in order to inform course design? Right, at the very low level, it could be, hey, here's a topic students don't understand, some formative feedback for us as instructors. But it could be more than that. We can learn a lot more, as Leah will demonstrate in a minute. So next slide, please. So what we're looking at this call for questions are opportunities to close the loop, as I just showed. And what we want to ask you is if you have questions about courses, programs, any level, that you think these questions could be answered by exploring the relevant data. There's a conceptual challenge in how do we turn a question into activity data? What activity data is a good proxy? For example, if you care about engagement in week 1 and 2 as predicting course performance, how do we define engagement in this course? There's also a technical challenge, anywhere from harvesting the data, processing it, to applying methods that allow you to understand and make sense of this data. And that's what we're here to help with overcoming these challenges. Next slide, please. So if you bring us your questions, essentially you will get to learn about your programs, students, courses. You'll contribute to this major UBC teaching and learning innovation. And that's a good way to demonstrate educational leadership and essentially to take up an opportunity to carry out research in scholarship of teaching and learning or discipline-based education research, learning analytics. Next slide, please. So if you bring us the questions, what we can do is work with you to offer clean data from the courses. So we will have here dedicated and skilled experts that help massage the data and turn data into information, and preferably actionable information that allows you to follow up on this. And you'll get an opportunity to engage with colleagues who actually undertake a similar experience. So Leah and I will give a couple of examples of what we mean by all that. Next slide, please.
Hello, everyone. I'm Leah McFadden from the Faculty of Arts, where I'm the Program Director for Evaluation and Learning Analytics. I've been asked just very quickly to give you a sense of the kinds of projects that fall under the very broad umbrella of learning analytics, or perhaps learning and teaching analytics. One area of work in the Faculty of Arts over time has been quite a lot of investigation about who our students are and how our student demographic is changing. So I'm showing you here an example of our changing demographics of student origins, countries of origin or regions of the world of origin over time. On the right of the screen, you'll see a prototype dashboard that we're developing to try to give instructors more information about who's actually in their course, or historically what's the likely composition of students in your course, not just about their origins, but about the proportion of students taking your course who may go on to major in the subject, who may have completed certain prerequisite courses, who belong to one program or degree area or another, in the hope that having more information about your learner group in your classroom, especially big classes where it's hard to get to know your students, might help instructors adjust their approach and know their students better. Next slide, please. A second area of interest in lots of ways, of course, is about trying to understand engagement with data. And we're looking at data from online courses, from MOOCs, and sometimes from hybrid or web-supported courses to try and figure out who's participating, how are learners talking to each other, who's more active, less active, does that correlate with performance in the course? What I'm showing you here is a sociogram produced from network analysis of an online discussion forum in online courses. And each of those nodes represents a student, and each line shows who they've communicated with. Really, it's showing us who's disengaged on the fringes and who's engaged in the middle, but we know things about those students and how they are eventually performing. So I'll hand over to our next speaker. Oh, have I got one? Apparently I have still one slide to go. Okay. I've been asked to continue talking about the data, just in case you're uncertain what kind of data we're talking about. The kinds of data in silos all over our campus include student information from the student information system, enrollment patterns information, everything about student performance. There's, of course, the course evaluation data, what students are saying about their course experiences. There's activity from our learning management systems and other learning technologies, activity data, discussion forums, not just what students click on, but what they write. There's MOOC data, and all kinds of student writing. There's also the potential to pull some open data, potentially, depending on your questions. Next slide, please. So finally, we just want to emphasize this call to you. We're looking for good questions to help us explore existing data, figure out what else we need, and complete that cycle so that we can make better use of data in our course design, in our teaching and learning, and share that capacity with colleagues across the campus.
Hi, everyone. I'm Stephen Barnes from the Department of Psychology here at UBC. I've developed a series of 6 MOOCs. Next slide, please. And those MOOCs were developed for advanced placement psychology. And they basically are a series of MOOCs that are intended to prepare students for the AP psychology exam. For those of you who aren't familiar with advanced placement exams, which are offered by the College Board, allow students to potentially get university credit if they get an 80% or higher grade on that exam. Next slide, please. So the courses we developed were self-paced courses, self-paced MOOCs. And interestingly, actually, only 8% of the registered learners actually reported taking the MOOCs as preparation for the AP psychology exam. That means that 92% of the people who actually were taking these MOOCs were actually self-identifying as just taking them out of interest in psychology. Next slide, please. So I'm currently in the process of making some modifications to those MOOCs. They had their first run in the past year. And I have a number of questions that I've consulted with Leah and Ido, who just spoke to you about, and one has to do with the conditional release of summative assessments and whether that increases attrition across the modules within these self-paced MOOCs. The second is whether the self-paced MOOCs format actually impacts the completion rates of the MOOCs. And the third is whether learners who complete one MOOC in the sequence carry on to complete the other MOOCs in the sequence. Next slide, please. So this is a visualization produced by Ido Roll and his team of the first course in the sequence of courses that are in the AP Psychology MOOCs. And it addresses the question to some degree of whether there's an impact on the conditional release of the summative assessments on learner retention in the course. And what you can see is that there is a suggestive drop after each black bar there in terms of the number of students that are actually completing graded problems and watching videos, which suggests to me that there might be some small effect of having conditional release. So I'm currently considering removing the conditional release, in part because students will be testing themselves repeatedly in practice for the AP psychology exam and may not want to go through every part of the course in order to do so. Next slide, please. So the other question I had was whether the self-paced format actually impacts the completion rate of these MOOCs. Next slide, please. And we looked at these data, again, using the visualizations produced by Ida Roll and his colleagues. And we found that we actually had approaching about a 20% completion rate, 18.8% completion rate, which is actually fairly respectable for MOOCs in general. If you know anything about MOOCs, it's typically a typical MOOC usually has a completion rate of about 10%. So I'm actually fairly confident now that the self-paced format is actually doable and is not causing a significant loss of learners. Next slide, please. And the last question I had in the short term, I have many other questions that we're looking at as well, is whether learners who complete one MOOC in the sequence of 6 MOOCs, since it's a sequence of 6 courses, actually go on to complete the other MOOCs in the sequence. And we've done a preliminary analysis of this, just looking at using these visualizations again from Ida Roll and his colleagues. And what we found was basically that the number of learners completing, let's say, course 1 actually is slightly less than the number of learners that are actually entering and initiating their activities in course 2, and this sort of pattern carries on through the other courses as well. So from a preliminary analysis, it seems to be the case that these students are actually carrying on. What we need to do now is actually look at the individual learners and see if they're actually carrying over based on their identification from one course to another. Next slide, please.
All right, so 2 or 3 presentations that I hope give you some kind of a flavor for the ways in which learning data is being used to both ask questions about how we can support student learning, what insights we can get into engagement or opportunities for improving course design. I want to open it up now for questions. So if you do have either specific questions for any of the 3 presenters, we're all sat around the same large table in the presentation room, so they'll be able to hear and answer any of the questions that people have. So if you would like to ask a question, please raise your hand, and the folks at Shindig will invite a few people onto the stage one at a time to ask their question.
It was just a question about something called conditional release. I was just curious what that means. There was I think it was Stephen Barnes who said there was, he was asking the question whether or not conditional release of information affected students' performance in the course. And I wanted to know what that meant because I did not understand that particular piece of research.
Okay, I'll let Stephen respond to that.
Thanks.
Hi, Alan. So conditional release in the context of MOOCs, and I apologize, I was using MOOC jargon probably there. Conditional release refers to the fact that you can, in a MOOC, at least on edX and probably other platforms as well, when a student completes one component in the course, you then allow them to access other components in the course. So for example, in my MOOCs, if a student completes quiz 1, which is a summative assessment, then they're able to access quiz 2, which is another summative assessment. And they can't access quiz 2 unless they first complete quiz 1.
Okay. And, yeah, I understand the question. Thanks. I mean, I understand the research. And what was the finding from that?
The finding was equivocal in the sense that there did seem to be some drop between modules, but it wasn't by any means dramatic.
Okay. Okay. Thanks.
Okay, so I think I saw Nancy's name on the list of questions to come up.
Yeah, so my question is about all the different sources of data. Leah had, or Ido Leah had the big list of data, different sources of data. How hard is it to connect the students in those different databases?
Yeah, that's a great question. Ido's pointing at Leah. Leah's pointing at Ido. It's a real challenge. I'll let Leah respond in more detail. Yeah, why not?
It's hard, but it's not impossible.
Mm-hmm.
We have some years now of experience working on joining these data sets. Learners and instructors have unique identifiers, and courses and terms have unique identifiers that allow us to quite closely join data sets. And within this project, we'll now have a much bigger team of IT specialists who can speed up that work of data joining.
Yeah, it's a great question. Thanks, Nancy.
Thanks.
We've got time for, in this segment, maybe one more question, if someone else would like to join us on the podium.
So I have kind of a follow-up question about the data sets. So if somebody is using open resource like UBC Wiki and the discussion forum in it, would it be possible to use that kind of data for some tracking and analysis? Has that been done?
It's a great question. So within tools like the UBC Wiki, can we extract data, say, from discussions around student use or engagement or particular useful things? I think Ido's going to try and respond to that one.
I think briefly following up on what Leah does, everything that students identify themselves in most of our systems, including the UBC wikis, their login name is being saved together with what they do. So as long as there's a student identifier, that's fine. If you use a wiki in a way that you don't need to identify yourself when you edit it, then you won't get it. Right? On Wikipedia, you can do anonymous edits. So whenever a student registers their identity for grading purposes, participation purposes, then we can use this information. And likely in most of the systems, we don't know of a system where we cannot do it yet. It's a lot of work, and that's a goal of this project.
Good, thank you.
Thanks, Ido. So in principle, yes, though, as always, the devil is in the detail or in the doing, as it were. And just because we can doesn't always mean that it's easy to do so. So, okay, thank you for your input on that. And as I say, if there are other questions that people have, please do submit them by the question mark. That's a text question that'll be collected by the moderator, and then they'll pass them back to us at the end of the session, and we will respond to the individual questions. So if you didn't get the opportunity, or you're sitting at home and don't really fancy coming up on the podium, then please feel free to send us a question or a comment in through that medium. Okay, next slide, please. I want to move us on to think about the second of the two innovation pilot areas, which is 3D learning. And unlike learning analytics, which had that neat, very clear definition from Solar, 3D learning is a little bit harder to pin down as a concept. So this is our take on trying to describe what we're talking about here. It's really a range of approaches, all centered around digital representation of 3D objects, allowing users rather to view, interact, and manipulate with them. Sometimes that can be done individually, sometimes that's done collaboratively. So it's a fairly broad term, and it incorporates approaches that are really relatively commonplace nowadays, moving along the spectrum to things that are very much cutting edge or emergent technologies. And so the sorts of visualization approaches that represent 3D objects on a 2D surface, so thinking about manipulation of chemical molecules and complex 3D structures, proteins and things like that, have really been around for quite some time, and there's probably already many examples of them being used in various disciplines around UBC. That's certainly part of what we're thinking of in terms of 3D learning, but that's really more established technology or capability that we can think about ways to try and enhance student learning using these approaches. So they're established approaches, but we might be able to find new ways to deploy them. Then we move into a sort of suite of applications or uses, which are, again, some of them are here now, some of them are more emergent. And these are really around augmented reality. So a real world environment which is augmented by other inputs, such as graphics or GPS data. Virtual reality, which is really simulating a physical presence within an entirely virtual environment. And then some combination of mixed reality, which is the coexistence of physical and digital environments. And this is the sort of thing that's often facilitated by the immersive technology and glasses and goggles that some of you may be familiar with. So if we could have the next slide, please. Here are just a couple of examples, and I should have said at the beginning, we will make these slides available. There's a couple of videos here that show examples of really either end of that continuum that I was talking about. The first one illustrates the use of Paint 3D within Microsoft PowerPoint. So it's the opportunity to be able to put 3D objects into Microsoft PowerPoint that can be manipulated by anyone who has the PowerPoint, whether that's the instructor or the students. And I think the particular example within that video is an olive tree that can be looked at in different representations. So that's the 3D visualization on 2D surfaces. The other video example is, and we won't play these videos now, but feel free, we'll send the links around afterwards. The other example is really a more cutting edge application with the Microsoft HoloLens around virtual reality and augmented reality in, I think it's in a healthcare setting. So just a couple of examples. But what we'll move on to now is 3 short presentations that show how these sorts of approaches and the technology and capacity for experimentation in these areas is being developed at UBC. So if we could have the next slide, please. And I will pass over to the next presenter.
Good afternoon. My name is Claudio Pini. I'm the Director of Teaching and Learning Services within UBC IT. So I will talk about the Emerging Media Lab. The Emerging Media Lab is a collaboration between UBC IT, CTLT, and some faculties. And it's one of the resources available to experiment with 3D learning. So it's a collaboration space for faculty, students, and staff to explore emerging technologies. Today, we are mainly focused on augmented reality, virtual reality, and mixed reality, but the idea is to continue to incorporate new technologies as they appear. Next slide, please. So the resources that the Emerging Media Lab provides are basically in 3 categories. One is hardware and development tools. So we have things like virtual reality equipment, we have Microsoft HoloLens, 360 camera, the Lightboard, and other technologies that are available. We have personnel that can help you explore these technologies and develop new tools and solutions. And we have space. So today we have space at the UBC studio, and we are working with other faculties to identify potential spaces in different buildings that can be converted into Emerging Media Lab spaces. Next slide. The main focus for the Emerging Media Lab are technology demonstrations and experimentations, training and knowledge exchange. So the idea that we can organize workshops or lecture series or knowledge exchanges with industries, and also visits to different companies that are working in these spaces around Vancouver. The third focus is exploration, so finding new technologies that could potentially enhance teaching and learning. And the fourth one is prototyping. So we can assign resources, again, space, hardware, and personnel, to work on new ideas for a short period of time as an incubation period. Next slide. Some examples of the projects that the Emerging Media Lab has been involved so far. One is the Vantage 360. That's a 360 video of a tour around the campus in Vancouver. for international students to get an idea of how the campus look. Geography VR, so there are a number of projects that geography is working on, including the geography virtual field trips. And Dr. Locke Brown will cover more about them later. HoloLens demonstration. So because we have the HoloLens in the studio, it's a great opportunity for faculty to experience with mixed reality and get an idea of what can be done with HoloLens. And the fourth one is the enhancing of the light board. So we're working on some initiatives to be able to add new functionality to the light board, be able to do live events using the light board, and also be able to combine virtual reality with the light board at the same time. So that's everything I have about the Emerging Media Lab. If you have questions or if you are interested in knowing more, there is a website. The URL is eml.ubcstudios.ubc.ca, and you're welcome to get there and get additional information and contact us. Thank you.
Hi, my name is Locke Brown. I'm with the Geography Department. I had a bit of an introduction there. And we've been working with virtual reality and augmented reality and a range of different technologies for a few years now with the help of the Teaching and Learning Enhancement Fund, as well as with the help of UBC Studios, to try to find ways to engage our students in the study of environmental issues and environmental problems. And environmental problems are complex and they're hard to learn in the classroom. You kind of need to have experiential and engaged modes of learning to kind of address these problems. But they're also they're dealing with complex natural systems as well as complex human systems and trying to look at the interface between these two systems. So we're really interested in exploring ways that technology could help us with that. And so we've worked with photospheres, we've worked with 360 videos. We're now working with virtual reality, using photogrammetry to build out photoreal environments that we then put into Unity game engine to build out interactivity. And we're really excited about the possibilities that I think these technologies open up for us. And I wanted to just talk about 3 areas where we see, at least for our purposes, these technologies being really powerful. And that is their ability to one of them is their ability to overcome the tyranny of geography, to be able to overcome the limitations of space in some kind of fundamental ways. Next slide. So, and there's a few ways in which I think these technologies accomplish that. One is that they allow students to go to places they can't normally go. So the high Arctic, war zones, the command and control center for disaster management in BC, an operating room. There's a lot of different places that it's either impractical or impossible to take students, but we can take them there virtually or in augmented realities. And so this opens up a lot of learning opportunities for these students in these environments. Next slide. And it's also about opening up spaces that aren't necessarily accessible to everybody. So in this case, differently abled people can now access spaces virtually that they might not be able to access otherwise. And we think that opens up learning opportunities as well. Next slide. And then the other way this kind of overcomes limitations of space is it allows people to jump around across space and do kind of comparisons of environments, spaces, places, phenomenon. So, you can imagine you could be standing on a street corner in Vancouver and then you could put on a headset and you're standing on a street corner in Hong Kong and you can do a kind of very immersive, visceral kind of comparison and experience of these two environments side by side. And that can be quite powerful for learning, we feel at least. Next slide. And this is an example of different farmers markets, for example, you could visit around the world, compare foodscapes and these kinds of things. Next slide. The second dimension, I think, is a temporal one, and these technologies allow us to time travel, and so kind of break down time barriers as well. Next slide. And actually, we'll skip to the next slide. For us, there's a lot of areas of geography that this can be quite powerful. You can go to a street corner in Vancouver and visit it physically, but then you can put on your headset and you can look at the street corner 10 years ago, but you can be standing there at the street corner, people walking by, as you're immersed in this 360 video. You can see what people used to wear back then. You can see the street, the stores back then, the cars. So you can see processes of urban change and gentrification, but in a very immersive way, ways in which, when you're talking about it, it's not quite the same thing as experiencing it. And same thing with a before and an after a natural hazard or a disaster. You can see this kind of, very real change to the landscape in a very visceral or immersive way. Next slide. And then it also allows for a lot of asynchronous learning opportunities. So students can go out into the field guided by technology at different times. And if we skip to the next slide, so if they go to Kiefer Street, if one of the students goes at night and sees it at the night market, and another student goes during the day and it's a very different street, and then they come back to the classroom and they compare these different experiences. So this kind of opens up new opportunities of learning in very asynchronous ways. Next slide. And then the third one, and we think this is really interesting for us as geographers, is the ability to engage in questions of scale in ways that we can't otherwise. So if we skip to the next slide. This is an example which we use from one of our field trips to a bog, and this is a cellular makeup of sphagnum moss, which is kind of the heart of a bog. It's what keeps the water table high and what allows bogs to remain or to exist. And so you can look at it at a cellular level, and if we skip to the next slide, the students can see what the moss looks like as an organism. You skip to the next slide. This is maybe where they are. They're in the bog. This is kind of the human scale. But then we can also, while they're at the bog, they can look at the microscopic scale, but then they can also start to kind of go up to the landscape scale. So if we skip to the next slide, here we can see the makeup of the bog and its kind of immediate surroundings. You go to the next slide, and now you see the bog within a kind of, an urban environment where, houses are starting to encroach on that small bog right in the middle. And then you go to the next slide, and you can start to see the bog within the wider landscape, and maybe you can talk about processes of why that bog emerged to begin with. So it allows you to jump across scales, and for us as geographers, understanding how global and local are connected is really hard to teach students, but this allows us to kind of find very visual ways of engaging them across scales with these phenomena. Next slide. So, I mean, we've been using a lot of these technologies. I was just going to mention one because it's a very simple one to use. If we go to the next slide, we've been using 360 photospheres, and the great thing about these is that you can make a photosphere with your kind of phone camera. So students are going out and making photospheres, and then if we go to the next slide, actually skip further, and one more. We can then take these photospheres, and using software, you can start to embed information into these photospheres. And students can do this. We've had students who've done tours of UBC Farm where they have a series of photospheres and they embed different information into these photospheres. And so when people go to experience, they can kind of get a sense for these environments and have augmented information added to these photospheres. And we give these assignments to students to create these kind of photospheres in these environments as ways of learning the material themselves. And then they can also be used for other people as learning objects. We skip ahead. So we've run a few field trips using these kind of photospheres with added information onto them. And we've actually found that there's no real good platform for delivering these. So we've actually written up some, it's called fieldpress.ca. But it's a WordPress plugin to be able to run these kind of field trips as well. And so that's kind of our experience in geography. I will say if anybody's interested in what we're doing, we have a website. It's Open Geography. If you put that into Google, it should come up. Open Geography UBC. It's open.geog.ubc.ca, and we share everything we do is open, so open educational resources. So you can download this platform if you want and use it, and you can gain access to all of our objects as well, and you can find them there. Thank you very much.
Hi, my name is Claudia Krebs, and I'm from the Faculty of Medicine, where I teach anatomy and, in particular, neuroanatomy. Next slide, please. So when we're talking about teaching about the brain, it's a very complex three-dimensional structure with a lot of really important nuclei on the inside. And the understanding of sort of the arrangement of these nuclei is really important to get an understanding of how strokes will affect different parts of the brain, how these nuclei are interconnected with each other. The challenge is that when we're taking the students to the neuroanatomy lab, we have a series of dissections that will show specific things, and you can see that there on one side where we've dissected the hippocampus out, which of course is important for learning. But you can only see that one structure really well because that was the focus of that dissection. The other thing we do is we take cross sections, and that is really where you can see all of the structures, including the hippocampus, in cross section. But it's really difficult to then translate that two-dimensional slice into the three-dimensional arrangement of nuclei within the brain. So next slide, please. And of course, as the students transition into the clinic, they'll be looking at the brain in two-dimensional slices. And they need to extrapolate the data from those two-dimensional slices that they'll get from MRI scans into a three-dimensional model in their heads that they can then, use to get an understanding of where damage is and what the implications are. So about 10 years ago, we took these slices and did 3D reconstructions of specific structures that we then put on the web. And that was, the sort of the state of the art at the time, and that worked really well. Next slide. So the advantage of that approach was that we were able to create a pretty comprehensive library of 3D learning resources for the students. And what the students would do is they'd bring up these 3D videos, or I should say videos with three-dimensional objects on their screens, and then they'd study the slices and they'd be able to pause the video and correlate that. So that worked pretty well, but there's a bit of a drawback. So if I can have the next slide, I'll show some of the limitations of this approach. One is these videos are pretty static. We create them and we take the students through it, and there's no interactivity built in. They're not really created for collaborative learning. The student brings them up and watches them, and they can watch them in groups, but there's no sort of trigger for collaboration built in directly. And the other thing is that the cognitive load for our students is actually really high as they're dealing with this. So it turns out we live in a three-dimensional world, and our brains evolved to function in a three-dimensional environment, and we process three-dimensional information all the time. And now all of a sudden, for the last 100 or so years, we've been putting three-dimensional objects into two-dimensional screens, really with the advent of cinematography. That's what we started doing. And it's actually difficult for our brains to then take that image from a two-dimensional screen and then recreate it as a three-dimensional object in our brains. Now, if you're watching a movie, it's telling a story and it's more about the story. But if you're actually trying to drive the learning of a three-dimensional structure, that becomes a pretty high cognitive load for the students. So as we're increasingly, experiencing the world through our two-dimensional screens, as we're constantly staring at our cell phones and getting information from that, we have to be aware that that actually takes a lot of processing power for us. So now, if I can get the next slide, please. So a two-dimensional image has a reduction in visual cues. It obviously lacks in depth. And we have to deal with that increased ambiguity as we're trying to extract information from that. So the mental effort is really higher when we're learning from a two-dimensional screen compared to when we're in a three-dimensional environment, when we're actually in a space or dealing with a three-dimensional object. And that's why bringing the students into a lab environment is really helpful, because they then interact with the actual brain. They have a 3D object in their hand, and that facilitates learning. But again, because the structures of the brain are quite complex and we can't dissect everything out in one particular prosection, students again have to start putting things together sort of separately. So now if I can have the next slide, we now have technology to take three-dimensional objects out of the screen and into the world. And what you see on this slide is a HoloLens that can basically take that object and project it like a hologram into the physical space. And seeing the three-dimensional object in the space is actually a really transformative experience for the learner. And I can tell you, as somebody who created these three-dimensional objects nearly 10 years ago, when I first saw them in a HoloLens where I could rotate them and take them apart and interact with them, it blew my mind. So I can only imagine what it will do to a learner when they walk in there and are able to interact with these objects virtually. The HoloLens is a mixed or augmented reality device, and what we can do is we can have several learners standing around looking at a three-dimensional projection and then interacting with it through, typical HoloLens gestures. So if I can have the next slide. And then if we can have the video going again and looping at the same time. So this is a student wearing the HoloLens, and you can see he's ready to interact with the device. And what the student now can see is a 3D reconstruction that can be dynamically manipulated, that we can rotate, where we can slice through it and correlate it to the two-dimensional anatomy, and really interact with it in a very meaningful way. And we can interact with it collaboratively since we're working together in a group. And really design the entire experience to meet very specific and complex learning objectives. So yeah.
Well, we've had 3 short presentations that I hope give you a flavor of some of the activities underway in this area, both in terms of the institutional support that's being provided to help people experiment and learn more about these areas, and then 2 really interesting but very different disciplinary examples from departments where this work is already well embedded into the curriculum and the teaching and learning approaches. One of the things I really liked about the geography example that Locke described was the opportunity for students to actually create some of this content themselves as producers using sort of commodity hardware, cell phones and devices that all of them now have. And then the advanced anatomical applications within Claudia's work within medicine, which is really sort of state of the art in terms of what can be done. I have no doubt the experience for students when they first sort of put these headsets on and have the chance to see that for themselves is very, very powerful. So we have a few minutes for questions. If people would like to raise their hands again and ask general questions or specific ones about any of the presentations that we've had on the topic of 3D learning.
Okay, I have a general question for the experiences with HoloLens from Claudia. Is there any analysis done for the learning experiences of the students from the HoloLens? Or that's just not in classroom yet? Or is there any data on that? Or
yeah, great question. So not yet. So we're we just finished designing the app, and we're running an educational study this summer, and we should have data to present in the fall on the effect of that. There has been work done about learning in 3D. There's the study that I cited there was a very simple origami folding instruction study. There it was found that people who learned in the three-dimensional environment learned how to fold the crane better than those who learned it in the two-dimensional environment.
Mm-hmm.
It's certainly something that I think is important for many of these studies. It's great to spend time and effort incorporating these into educational experiences for students, but one of the things we need to make sure we can get some kind of a handle on is what the impact is. How do we know if it's been successful? What's effective? Many of these approaches might be engaging, but not particularly effective for student learning. And I think wrapping some research and evaluation around these projects is going to be really important. And I'll get to that in my closing remarks about how we want to try and gather your feedback and your interest to develop some of these ideas. So we have a question from John Dill. So if we can promote John to the front of the room.
My question really is directed at the speaker about the neuroanatomical applications. And as much as our brains are adapted for working in a 3D world, my experience in teaching students to think in 3D and create 3D objects is that it doesn't come so naturally. And I'm wondering what sort of difficulties you may have encountered in the 3D anatomy course, in just the fact that students sometimes find great difficulty in translating things like cross sections into a 3D structure.
Yeah, I think that's
Basically,
the
are they
biggest
natural
challenge is
3D
really
things?
that 2D to 3D transition. The creation of the 3D structures was done by us. So we took MRI scans and reconstructed those images three-dimensionally. And so asking the students to sort of draw it out is difficult. And I mean, I do a lot of chalk drawings when I talk to students in small groups. And I think I've talked about this with some of my senior TAs. What I see and what they see is very different from what the students see. Because when I start sketching out, I don't know, the structure of the caudate nucleus, immediately people who have worked with the three-dimensional model will see it three-dimensionally, whereas people who've worked sort of only in slices and see me drawing it two-dimensionally on the screen are mostly confused at what is going on there. So the aim is really to allow students to have these complex structures as a three-dimensional object in the room. So it just becomes natural to see it there. It's just as easy to understand as any other structure in our environment.
Okay. Well, okay, if we could have the next slide. Thank you for that input with the questions, and I'm looking forward to seeing what comes back to us in terms of the text questions that people didn't have the opportunity to ask interactively. I just want to close in the last couple of minutes by wrapping up and telling you about next steps. I said at the start, one of the aims here was to try and stimulate your thinking and gather your input and ideas. And in the last couple of minutes, I just want to give you some information on what you can do with those ideas if it's prompted questions and other input from the presentations that we've shared today. And as I said earlier, one of the things we want to do in moving into these innovation spaces or exploratory spaces, we want to make sure that we're spending time investigating questions and topics that matter to people coming out of their teaching and learning within their different disciplinary contexts. So that's really the call. It's a call for not proposals, quite deliberately, as I said earlier. These are not meant to be fully formed research projects or enhancement projects, but really, even at the level of this is an interesting question, I'd like to explore how either learning analytics or 3D approaches might be able to shed some light and help me develop my thinking here. So what we've put together is a short online application form. It really is short. It's a series of about 6 questions. There's a separate form for learning analytics and for the 3D area. And given that we're entering the summer period where I imagine people will be taking some time off, maybe attending conferences, rather than have a fixed application period, we're going to open this for a 3-month rolling application window. And what we'll do is we'll review applications periodically, say once a month over the summer. So essentially, this is open until the end of August, open through June, July, and August. For people to submit their ideas, their suggestions, their topic areas that they think are worthy of further discussion and elaboration, with the aim that hopefully 5 to 10 areas or developed ideas per theme will be part of ongoing conversations and supported to take those forward. Next slide, please. So there are the 2 links to the 2 separate application areas. If you go to the lthub.ubc.ca website, you'll find them both under the current projects tab. And these are separate short forms to submit topics or questions or ideas for areas of future exploration. As I say, we'll have the rolling submission window open for the next 3 months. We would like to come back and showcase some of the emerging ideas later in the fall semester. And if there are any other questions that aren't specifically related to the areas of analytics or 3D learning, then there's the general lt.hub@ubc.ca email address there, and whatever the question is, that can be passed on to someone who will be able to answer it. So we'll wrap up here. I'd like to thank everyone for their participation, for their engagement, in some cases their patience as well. This is a piece of new technology for us. We've never done something like this with this platform before. And as usual, when you try any new piece of technology, there are some interesting wrinkles and kinks to iron out. But it's been an interesting experience for us doing this online. And thanks once again to the folks at Shindig who helped us set it up and were moderating for the session. So thanks again, everyone. And if there are any other questions, then do feel free to submit them through the question button before you leave the room. Thanks very much.